All right, so today we're going to talk about momentum. We talked about momentum once before, and don't write any of this down, but these are the types of questions that we are going to learn how to do. We did this earlier, like when we were doing linear motion, and we talked about it briefly, but now we're going to get into collisions, elastic and inelastic collisions, and get more in depth in the calculations, because a roller coaster has carts that are attached to each other, and it has momentum. So when you think about a roller coaster, we got to figure out the momentum it has too. It's another way to figure out how high the next hill has to be. All right. So I'm just going to read through these questions real quick. Calculate the momentum of a 1 kilogram object moving with a velocity of 20 meters per second. What is the velocity of an object with a momentum of negative 30 kilogram meters per second and has a mass of 3 kilograms? Two objects have equal momentum, but one has 4 times the mass of the other. What is the relationship of the velocities? So when you go to a car crash, police officers determine how fast somebody was going based on calculating the momentum. Now, they probably have an app that does it nowadays, but back in the day, they just write it out. Okay. Here are a couple more questions. Which answer shows the correct units of momentum? We'll talk about that. 2 bowling balls have a mass of 4 kilograms each. The red ball is moving at 2 meters per second, and the blue ball is rolling at 1 meter per second. So momentum comes into play there. Write this down, though. Momentum, and you'll be like, what? Momentum, it always takes my computer a second to catch up. We'll try this again. There it is. This is momentum. And you're like, why'd they use the letter P? Well, we're already using M over here for mass. So momentum is the mass of the object. What's the unit for mass? Kilograms. And then what do you think V stands for? Velocity. Yeah. And what's the unit for velocity? Meters per second. So momentum's unit is kilogram meters per second. Okay. And it is a vector. So what does the vector mean? It has a direction. So remember that when we say vector, we have a magnitude. That's the number. I think it's an I-tude. That's your number, your value. And then it also has a direction. For most of the stuff that we do, the direction will be positive or negative values. Thank you. Okay. Oh, I lost my place here. Where's my mouse? There it is. Or negative. This is for you. Come get this. All right. So just like before when we say positive velocity, negative velocity, and all that stuff, we have positive and negative force. We have positive and negative. Anytime that we have a vector, positive usually means we're going one way, negative means we're going the opposite. In a college level physics class, you would figure out the exact angle, but most of the time you separate it into the x and y, so you'd have a positive x and a positive y, and negative x and negative y. Okay? Does everybody have this written down? All right. Can I move on to the next slide? Okay. So here, I have 1 kilogram sphere, which is moving at 100 meters per second. And I have a 100 kilogram sphere that's moving at 1 meter per second. So the question is, if you apply the same amount of force, which one will stop first? Well, let's think about the momentum of this, right? So let's calculate that. So remember that momentum, P, is equal to the mass in kilograms times the velocity. So the mass over here is 1. So let's calculate this. The mass is 1 kilogram times the velocity, which is 100 meters. Oops, it always does that. Per second, or 100 kilogram meters per second. Now let's do it for the other one. So for the other one, we're going to say that the momentum, the mass is 100 kilograms. Times 1 meter per second. Well, that's the same thing, isn't it? So they have the same momentum. So what do you guys think? If the same stopping force is applied to each of them, which sphere will stop first? Will it be the red one or the green one? Let's see. Show of hands. How many of you think it'll be the red one? Okay. How many of you guys think it'll be the green one? How many of you guys think they'll stop at the same time or it's a tie? It's a tie. They would stop at the same time because they have the same momentum. Okay, did everybody get all that math copied down? Okay. Now, I know what you were thinking. A lot of you guys are thinking, well, that little tiny red one would probably stop faster. If they had the same velocity, the red one would definitely stop faster. But think in terms of energy. Think in terms of kinetic energy. They would have very similar kinetic energies. Well, actually, no, they'd have way different kinetic energies. But momentum is what we use. Because remember that momentum is the mass of the object times the velocity, and then also remember that force is mass times acceleration. Okay? And acceleration is just the change in velocity over time. Yes? Yeah. 5, 6, 7, 8. So why is that? Well, their momentums are the same. Okay? And we've already written this down, but momentum has a mass of kilogram meters per second, right? I wrote that down on the first slide. I have a bad habit of doing that. I just teach you everything all at once. I'll teach you all the slides on the first slide. Okay? But if you didn't write it down on the first slide, write it down now. It's kind of important. What time do we get out of here? 45 or 50? I posted it in Canvas. Okay. Just want to make sure I have enough time for you guys to do your homework. Okay. Or at least get a good start on it. Also, remember that velocity is a vector. What does that mean? Well, it has a magnitude and a direction, right? So momentum is also a vector. So when we look at these two problems over here, because it has a direction, if I make going to the right, and by the way, you need to write this example down. If I make going to the right the positive x direction and going to the left negative, and then I do the math, right? The math is, for this one, the momentum would be, the mass is just going to be 100, or not 100, it would be 10 kilograms. But the velocity is going in the negative direction, so it'd be negative 10 meters per second. So that's where that negative 100 comes from, right? Now over here we have the same thing. We have the mass times the velocity, which is, the mass is 10 kilograms, times a positive 10 meters per second. And that's where you get this from, a positive 100 kilogram meters per second. Now it says, what's the total of the system of these two? Well, you just add them up together, this plus this, which is 0, right? I'll give you guys a second. I kind of forget that you guys have to sketch out the picture, right? You got to draw the little arrows and show where things go. Now this is, we did this a little bit last fall, but when we didn't do a lot, we didn't get into the collision side of it a lot in depth. Okay. So this might be a little bit of a review from the fall, but then when we start to do the differences between the collisions and do the math. Okay. So again, 100 minus 100 equals 0. Does that make sense? All right. We're going to try to do these problems. You do want to write the words down. So it says, calculate the momentum of a 1 kilogram, that's a mass, right? Object moving in a positive 20 meters per second. So for this one, remember that the momentum is equal to the mass of the object times the velocity. And remember, this is your velocity here. So I'm going to have 1.0 kilograms, bless you, times positive 20. I only bless the first sneeze. So that's just 1 times positive 20 is positive 20. Now, if you were to write positive 20 on a test or something for me, I wouldn't mark it wrong. It's not wrong. But we don't have to write the positive down. It lets me know that you realize that this thing, and you know, most of the time we consider going to the right positive. Okay. Or in some cases we consider going up positive, right? Okay. but this is the answer. So for question number 2, it says, what is the velocity of an object that has the momentum of negative 30? Well, that's the momentum, isn't it? Kilogram meters per second. And a mass of 3 kilograms. All right, so the formula is momentum is equal to the mass times the velocity. We need to find the velocity. So we need to solve for velocity. So I'm going to divide this by m, divide this by m. So my new formula is that the velocity is equal to the momentum divided by, what the heck? The mass, which is negative 30 kilograms meters per second divided by 3 kilograms. One thing I should probably point out is that kilograms divided by kilograms cancels out. So that means that my final answer, negative 30 divided by 3, is negative 10. And notice the only units remaining are the meters per second, which is good because I'm solving for a velocity. Okay. So this is a fun one. We have 2 objects. So I'm going to say object 1 it has momentum 1. Object 2, and I'll abbreviate because I'm running out of room, has the same momentum. Okay? So really, we don't need to say object 1. We'll just say, we don't need to say momentum 1, momentum 2. We'll just say momentum. Okay? Now, this has a mass, but it says one of them has 4 times the mass. So the mass of object 2 has 4 times the mass. And then it says, what is the relationship? We'll call this V1, V2. What is the relationship between their velocities? So if I want, I could think of object 1 as being the mass times the velocity. The first velocity is equal to the momentum, which is the same momentum as the second object, which is 4 times the mass of the second velocity. And if I divide both sides by m, I get v1, and then we'll just skip the middleman, right? We don't need to even insert the p because they both equal the same thing. Is 4 times the velocity, right? So you could say velocity 1 is equal to 4 times the second velocity. And then in parentheses, say 4 times the mass. So what does that mean? That means it's more massive, but it's slower, 4 times slower, right? Or if you did a little more algebra, you could say that 1/4 of V1 is equal to V2. Same thing. Okay. Does everybody have this written down? All right, let's do the next one. Can I move on? Or do you need a second? I see some people looking and writing down, so I'm just checking. All right. Does everybody have everything written down? Well, what's the unit of measure for momentum? Which one? A, B, C, or D? What do you guys think? C. Yeah, just look at your notes. It's C. And if you weren't sure, remember that momentum is just the mass times the velocity. Well, mass is measured in kilograms. Velocity is meters per second. Okay. Can I move on to the next one? All right. Last thing, and then I'm going to let you do your homework. Two bowling balls have a mass of 4 kilograms each. So I'm going to label that because it's going to, this is a mass of 4 kilograms. We'll call it M1. We'll call this M2, 4 kilograms. The red ball is moving at a velocity of 2, and we'll make this positive, and we'll make this negative. Plus 2 meters per second, because it's a positive 2 meters per second, which means it's going this way. That's what that vector represents, the velocity. And then the blue ball is just going 1 meter per second. We'll call this V1 because it's associated with the first object. We'll call this one V2 because it's associated with the second one, but that's going in the negative direction. And they say east and west. So you could call, if you want, you're going to say that going east is positive and going west is negative. Okay? What's the total momentum of the system? Well, we're going to say P1 plus P2 equals the total momentum of the system, which is going to be M1 times V1 plus M2 times V2. So this would be 4 kilograms times 2 meters per second plus 4 kilograms times negative 1 meters per second. So you get 8 minus, oh no, we didn't want to do that. Oops. 8 minus 4 kilogram meters per second, right? Or positive 4 kilogram meters per second. So we're starting to get into collision. So if this happens, if the total momentum of the system is plus 4, it's going to be 4 kilogram meters per second to the east, right? So when these two balls collide, what will happen? They're both going to turn around and go this way. Well, one's just going to keep going, but it's going to slow down because it did have a momentum. I might be getting ahead of myself. But even though they're the same size, the red ball is going to push the blue ball and cause it to change direction. that make sense? Because the overall momentum will be positive 4 kilogram meters per second. So that means it's going to go this way. So you're going to have the red ball going this way. Then you're also going to have the blue ball going this way. Now, whether they stick together or they separate, that's for the next time we meet, okay? Because there's some extra stuff that happens if they stick together or if they separate when they bounce and collide into each other. All right, that's all I got. Does everybody have everything written down? Okay, give me a second and I will post your assignment for today. And I'll post this stuff too.